Welcome to today's lecture. Myself Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad. The subject that I am covering in my lecture series is Embedded System. Subject code is KOE 062, which is open elective. The topic that I am going to cover in this lecture is need for device drivers. So, what type of device drivers we are talking about? Whenever we want to connect some hardware device with our system, with our PC, then it requires some device drivers to run it. So, we are talking about those device drivers. Device driver or the hardware driver refers to the special kind of software program or a specific type of software applications which controls a specific hardware device that enables different hardware device for communication with the computer's operating system. So, what is happening basically is that it is a software or the program we can say, and which is of a specific type of software application which is controlling a hardware device, thereby enabling the different hardware devices for communication with the computer's operating system. So, it is easing the communication between the different devices and the operating system. A device driver communicates with the computer hardware by computer subsystem or computer bus connected to the hardware. Device drivers are very essential for a computer system to work properly, because without these device drivers the particular hardware fails to perform the intended tasks which has been done, which has been allotted to that particular device. So, without device driver we cannot think of using the particular device to perform the intended functions. So, why do we need the device drivers? Most embedded hardware requires some type of software initialization and management. So, this is the basic need of the hardwares. The software that directly interfaces with and controls this hardware is called a device driver. So, basically when we are talking about the embedded systems, embedded applications, so in each of the embedded application or a bigger embedded system, we are having the various hardware devices which are embedded to each other, which are embedded in the system and which are connected to each other. So, to run all those devices we need certain softwares to help in the proper functioning of those devices, hardware devices. So, those special softwares which helps in organizing, which helps in initializing, which helps in controlling those devices, those hardware devices embedded inside an embedded system, that those special softwares are termed as device drivers. All embedded systems that require software have the very least device driver software in their system software layer. So, when we are talking about the embedded system and when we are talking about the devices, various hardware devices embedded inside that system, so this having this device driver, having this software system, that is a special software system, this is a very essential, this is the at least essential need which must be fulfilled before using those hardware devices. So, these are the software libraries that initializes the hardware and manage the access to the hardware by higher layers of software. So, if we want to access the devices, access the hardwares from the higher layers of software, so the device drivers are very much essential. They depend upon the operating system's instructions to access the device and perform any particular action. So, when the operating system gives certain command to use the particular device, then only the device drivers comes into play. After the action, they also shows their reactions by delivering output or status or the message from the hardware device to the operating system. So, after they perform their particular function, the intended or the demanded function, then they also react by acknowledging the request, by sending the message from the hardware device to the operating system. For example, a printer driver tells the printer in which format to print after getting instruction from the operating system. So, there is the software driver, that is the hardware device driver between the operating system and the actual printer. Similarly, a sound card driver is there, due to which ones and zeros data of MP3 file is converted to the audio signals and we enjoy the music. So, these are the two perfect examples of the device drivers being used in our embedded systems. Another very good examples of the device drivers are card reader, modem, network card, sound card, printer, video card, USB devices, RAM, speakers. These all need the device drivers to get operated. So, these are the basic devices which we come across in our day to day activities: card readers, modems, network card readers, sound cards, printers. All these are the devices which we come across in either of the activities, in our day to day activities. So, to operate all these devices, we need the device drivers or the software programs to be installed which are capable of running these devices. So, this figure is illustrating how the device driver comes into play and how the device drivers helps in connecting the operating system with the lower levels of devices. So, this is the user, we are running certain application. So, this is the flow. Now, that application will send a message, will request the operating system to work. Operating system will then ask the device driver to operate the device. Device driver will then initiate, will then manage the working of device. So, this device is basically the hardware and this is the upper part is the software part. This device will acknowledge the request from the user by sending its response to the device driver. Device driver will in turn send the response to the operating system. Operating system will send the response to the application and application will finally send the response to user and we will get the desired task done in minutes. So, this is how the device driver is acting a special role to connect the higher levels of software, these are the higher levels of software to the hardwares. So, this is the hardware layer, the device is under the hardware layer, this is the software layer, that is the application and the operating system, and the device driver is the intermediate between these two. When we talk about the types of device drivers, so these are classified into two types: kernel mode device driver and user mode device driver. When we talk about the kernel mode device driver, it includes some generic hardwares which loads with operating system as the part of OS. So, these are BIOS, basic input output systems, motherboards, processor and some other hardwares which are the part of kernel software. So, basically kernel mode device drivers are those device drivers which helps in running those hardwares which are the part of kernel, which are the part of our operating systems. Just suppose when we talk about the basic input output systems, motherboards, processors, what we all know that these are the parts of the operating systems. So, all these comes under kernel mode of device driver. These includes the minimum system requirements device drivers for each operating system. So, these device drivers are having at least the minimum functionalities to operate these devices. When we talk about the user mode device driver, other than devices which are brought by the kernel for working of the system, the user also brings some devices for use during the use of a system, that is use of an embedded system. Those devices basically needs certain device drivers to operate the devices. Like suppose, as we have already discussed, suppose we are using a printer. So, as a user we want to operate the printer, and for the printer to get operated we need a device driver basically related to that printer. So, those devices need device drivers to function the properly. So, those device drivers falls under the user mode device driver. Plug and play actions that comes under this. When we use the plug and play devices to be connected to our PC, to our system. So, for those plug and play devices to get into action, we need certain device drivers related to those plug and play devices, which should be installed in our system, which should be installed in our within the software of our embedded system. Similar is the case with other devices, with other hardware devices which we want to use. So, in this way the each and every hardware device which is connected in our embedded system, which is embedded in our system and which we want to play, which we want to operate, though every device should be having the device driver installed in the system. Another category of the device driver is the virtual device driver, also known as the VXDs, which manages the virtual device. Sometimes the condition occurs when we use same hardware virtually. At that time, virtual driver controls or manages the data flow from different application used by the different users to the same hardware. So, it is essential for a computer to have the required device drivers for all its parts to keep the system running efficiently. So, this is the case when different users wants to access the same device, same hardware device. So, in that case, suppose the different users are connected to that particular device virtually. So, we want to use that device in the virtual mode. Now, this for the device to be used in the virtual mode, it is very essential to keep the required device drivers for a remote computer to get installed in that system. So, so that all the devices are easily accessible from the virtual users. So, many device drivers are provided by manufacturers from the beginning, and also we can later include any required device driver for our system. So, many a times we feel that when we are connecting certain new hardware to our system, so its compatible device driver is not installed in our system. In that case, we used to install a device driver for that particular hardware. And many a times we need not install those hardwares, because when we purchase our systems, those hardware drivers are already installed in our PC. So, this is how the device drivers, virtual device drivers can be used to access the remote devices virtually by the multiple users at a time. The various device driver features are, it has having the different code in different operating systems. So, when we are using the different operating systems, we need to make the changes to the code which are compatible with that particular operating system. Same device may have the different code for the driver when the system is using different operating system. So, this is how when the operating system changes, the coding may also change. So, we need to know that if the coding that we have done is compatible to a particular operating system or not. otherwise we have to make the changes to the code. Does the interrupt service for any event related to the device and use the system and input output buses required for the device service. So, various interrupt services are also handled using the device drivers. So, whenever a particular interrupt service comes for a particular device, then that interrupt service is handled, is acknowledged and is executed, that is related to a particular device. And also that particular device can also interrupt another device for its functioning, for the accomplishment of the task. So, in that case the nested interrupts can also arise. So, and the system and the input output buses are efficiently utilized in that case for the device service. Device drivers can be considered software layer between an application program and the device. So, after so much of discussion about the device drivers, we can come to a conclusion that the device driver is nothing but a software layer between an application program and the device. So, whenever as a user we want to use any device through certain application, so we always start with an application, user application, we trigger an application and that application will trigger the operating system, that operating system will trigger the device driver will in turn operate the particular device which we want to operate, and then as an user we want the desired results. So, this is how the device driver performs its task of managing the particular device. Now, how the interrupt service routines are executed in the device drivers. So, what is an interrupt? Firstly, we should understand that when we talk about the interrupt, interrupt is nothing but an external event which triggers our main flow of task. So, when a particular device is performing its task and some other external event occurs at a particular time, then it is based on the priority of the interrupting routine. So, either it should be executed or it can be delayed. If that particular interrupt is not maskable or it should not be delayed, then that particular interrupt is acknowledged and is executed by the operating system. So, when a particular interrupt occurs, or we can say an external event triggers our main flow of the program and it needs the access to a device for service, that is configuring, initializing, activating, opening, attaching, reading, writing, resetting, deactivating or closing. So, all these services which I have mentioned in this slide, these are all related to a device. These are all the functionalities which a particular device can perform or we can perform on a particular device. So, whenever the interrupt service routine occurs, it will trigger any of these services, any of these functions. Interrupt service routines thus implements the device functions of the device drivers. Now, suppose it can happen that we trigger a particular device, but that particular device needs to trigger another device, needs the help of another device to accomplish its task. So, as a user we start certain application, but as a device it may interrupt another device to accomplish the allocated task. So, in this way interrupting routines takes place, interrupt service routines comes into focus. As an example, we can see that application program commands to write on the display screen of a mobile the contact names from a contact database. Suppose as a user I want my device to display the names which are there, which I have saved in the contact list of the mobile phone. Now, what I will do? I will start certain application, that is I will start certain icon which is available in my phone, and I wish to see all the contact list given in my phone. Now, I have started a contact names display application. This application will in revert sends an SWI to call LCD display device driver. What is this SWI? Let us focus some points over this SWI. This is the software interrupt. Within a device, within a processor, there are two types of interrupts: hardware interrupts and software interrupts. Those interrupts which are those external events which triggers the main flow of the program through the pins, that is those events which comes to the processor through the pins, those are the hardware interrupts. But those interrupts which we implement using the software program, those are known as the software interrupts. So, when we talk about the software interrupts, it means it executes a certain program to call the LCD display driver. So, we initially started certain application to display the contact list of all the contacts in our mobile phone, but in turn it triggered another program, that is of LCD display device driver. The driver runs short code and executes another SWI to call the ISR related to the write function at the LCD. Now, we gave call to the LCD display device driver, but LCD display device driver gives calls to another program that is used to write the contact names on the display. So, that is another device driver program. So, what is happening, that we gave call to the LCD, but now LCD is giving call to another function, that is a write function at the LCD. So, this is the ISR related to the write function. ISR is what? ISR is interrupt service routine. Interrupt service routine is nothing but a small sub program which is used to execute the special functionality. Interrupt is, that is the functionality of an interrupt. The device drivers does that without the application programmer knowing how the LCD device interface in the system, what are the addresses by which it is used, what and where and how used are the control registers and status registers in that. So, what it is trying to tell, our main purpose was to have the contact list on the display device. So, we opened an application which can display the contact list on our device. But behind this functioning, what is happening, that LCD is giving the request to another software program which is used to write the content on the screen. So, LCD write function is being called, and that write function is having its own commands, it is having its own registers, status registers, control registers. So, we need not bother about those control and status registers. So, we just gave the command to LCD, LCD gave command to another function. This is how the interrupt, nested interrupts takes place, and this is what is depicted by this figure. We gave command to one driver, that particular device driver runs another interrupt signal. Similarly, this command is given to another driver, then again the device driver interrupts, sends an interrupting signal to again another program, that is another interrupt service routine. So, this is how the first level ISR and the second level ISR approaches to handle the device hardware interrupts followed by the software interrupts. So, this is how the various device drivers work in mutual agreement with each other, and the the particular device displays all the functions which it is intended to display. So, this is how the device drivers comes into action when we actually want to communicate with a particular hardware device connected to our system. Thank you, that is all for the day.